Now, we're talking about creating a Docker file. We're about to create a container. We're about to create an image, not a container. This is a Docker file. Docker files create images. Images can be then used to create containers. So this looks pretty good. I won't expect you all to know this by heart. I put it in the slideshow that's in the daily plan. So when we do the we do in a minute, you can use that as a cheat sheet and we can do it together. Or when we do another repetition of this. So go in our terminal. What I want to do, I want to create a new terminal window. And what I would like to do is I would like to build this image. So I can do Docker build -t and then give it a tag name. And so we will just call this Lunis. And then dot for here. Docker build -t Lunis. So we're building it here. Now, before I do that, let me just copy this. If I do Docker images, oh, I didn't start Docker. So you're gonna have to start Docker on your machines and get the daemon running in the background. Docker desktop is running. Well, it's starting. Oh, I didn't sign in either. Let me see if it'll let me sign in while we're waiting. Yes, I want to open Docker because I already have it open. It's verifying my credentials. It signed me in, but the daemon is still taking a while to run. It usually doesn't take that long, but you know, just blame it on the wheel of names. But while this is going, we can talk about some other things in here. This, go back to IntelliJ. I don't want that one. Remember when we were talking about in this slide here, when you have the env, env declares an environmental variable. So you do env, the name of your environmental variable, and then the value of the variable. So, and I gave you the slide so that you can do this yourself. Instead of exposing 888, we can create an environmental variable. It's a common convention, just to the port like we had there, and then make that 888. And then you can expose your interpolated port very much like you did in like interpolation in Java, right? So expose port and then run your server on the port. Make sure there's spaces behind everything. Let's go back to Docker. Wow, I don't know why it's taking so long. Okay, finally, wow. Well, yeah, during the udo section, I may have to reboot again, just not use the wheel at all. All right, so if I go to images here, I've got a bunch of images on here, right? I'm going to close this Docker desktop. I don't like using a Docker desktop because you get everything you need in the terminal. So now when I do Docker images, you'll see all of those images that were listed before here. These are all the images that I currently have, right? So what I want to do is I want to do Docker build -t, and I'm going to give this the name of the image. We said it was called Lunis, and I want to put a dot for here. So when I do Docker build -t, then it's going to go download this image. It's going to make the directory inside of that image. It's going to set it as a working directory. It's going to copy all of our files, which is, right now it's only index.html, into the working directory. It's going to, we set an environmental variable that's a port. We expose the port, and then we actually run the server. And you can see it's doing these things now. It's at least setting up a container that has the, setting up an image that has all this stuff in it. So it exported it, exporting layers, all this. It's naming it. And it's finished building it. So now if I hit the up arrow twice and I do Docker images again, you'll see at the top of the list is Lunis, what we just started. We just created that image. Now, if I do Docker PS is basically, PS is short for processes. It shows there are no current Docker processes running. So we've got some vocabulary here. The first one we did, and you probably should have a section in your notes for Docker. Your Docker file is the blueprint. Building it with Docker build makes an image, and then running an image creates a container. Yes, we see two hands here. Oh, yes. 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 You know, that's a really great question. I've had the same question. I don't know actually when to use the strings as to using these raw commands like that. I can say that if you're doing a lot of really verbose commands, especially using like Docker Swarm and these other types of, where you have a lot of text, I've seen people using quotations for that. But I'm not exactly sure why sometimes we just use the raw command in the string. I've used both. I don't know. I think that's a great question. I don't know the answer to that. All right, so we have these three here. We know that the Docker file creates a blueprint. You can build it, and then you can run it. All right. So now what I'd like to do, we're gonna delete this. That was I do. We're gonna do the we do. We're gonna build this. We're gonna do this over again. You can use the cheat sheet, and actually, rather than typing everything over again, why don't we just get people? I'm gonna get people to tell me what each of these lines is actually doing. That way, we're still doing it without having to type everything over. All right. So the first line, Jamal, can you tell me what the first line does? Okay, very good. Aiden, second line. Creating a directory inside of the image. Very good. And Aiden, which operating system did I say that the Python was based on? Which OS? It's some Linux distro. Yeah, it's some Linux distro. Right, exactly. Yeah, we don't really know exactly which version of Linux. I think this one is actually based on Slim, and you can go to Docker Hub, and it'll tell you when you drill in there. My computer's running really slow, but if you go into Docker Hub, there's an image called Slim, which is a slim version of Linux, and I bet that Python RC, 3.12 RC Bullseye is based on Slim. Y'all can look it up now if you want and see, but I think that it is. So then let me see. Tom. Is Tom here? Yeah. So work dear web. What is this doing? Right. Very good. All right, Reyes. This line, number 7, what's this doing? Reyes, you're muted if you're here. Yes, sir. So this line here is line 7. What is this line doing? Oh, you know what? I forgot to capitalize this. I don't think it matters, but you should copy the actual commands. Okay, Les, do you want to help him out? Oh, you don't know? Trey. Oh. Almost. So, Neo, what does copy mean here? What's the copy doing? Exactly. So we're copying what the dot means here. Always remember, everywhere in computer directories, when you see a dot, dot means here. So we're copying the here from inside of what? Yeah. So here from inside of right here, what Neo said. This, like our current directory, is inside. We're copying index.html, and then we're copying that into this other dot means here. It means this here for the working directory. So copy dot means copy from this one into this one, right? And then Esteban, env port 888. Do you remember what is env? What is env? You can use the slides too if you want to put the slides in the daily plan as a cheat sheet. All the answers are there. Yes. Awesome. Very good. Okay, so we've done all of that. And then we expose here. Okay, so expose. Ian, what is 11 doing? Absolutely. Right. Very good. Okay, and Terrence, this last line. That's right. Yep, the command is going to run that server off the port that I exposed. So, and this is the same command we're using locally. So let's actually run the container. Well, so actually, we built the container already. So I did docker build -t, t is the tag, and I called it Lunis. I'm not going to build it again. And then I did a dot. So Craig, what's that last dot there doing? I didn't say what it was, but what could you guess that's doing? Yeah, it's built at the current location. Because if you just do docker build -t lunes, but you don't give it anything, and I hit enter, it's gonna crap out because it's say, well, wait a minute. Docker build requires exactly one argument. The one argument is the location, of where the stuff is. If it were somewhere else, pardon me, it's the path to the yes. Absolutely, yes. It's the path to the Docker file. Absolutely, yes. So if the Docker file were not located, in here in that directory, you would have to say, .. like that to the path to get up to where it is, or if it's in, admin there, wherever that file is. But for now, we're just doing dot for everything. Okay, so we did that. We already did Docker build. And then now, if we do Docker, so now we did Docker images, we saw that we have our image that we just built as Lunis. So then now, we're going to do Docker run -p, and the P is for the port that we want to run it on. When you tell Docker to run something that's a server and you're passing it a port, you need to give it 2 ports. The first port is the port on your computer. And I should have put this in the slides, but y'all have to listen because I'm going to ask one of you on this. So just listen up to this part here. I can't Control plus zoom inside of here, and I can't pinch zoom inside of here either. So you'll just have to, hopefully you can see. So Docker run -p. Let's say on my local computer, I want to run it on port 8123, and then I put a colon for the port that it's running from inside of the container, and that one is port 8. That one is port 8888. So you always want to run. You can Docker run -p. That the P is a flag, which stands for port, and then the first port is the port you're running on your computer. And the second port, colon, and the second port after the colon is the internal port from the container. The way I like to think of it is that when you first talk to a port, you first start talking to the outside logic. You're thinking about outside logic, and then when you do the colon, you do the inside logic. So you always do with outer before you do with inner. I mean, that's the way I just think about it. I don't know if it makes sense to you. But Docker run -p, outside port, colon, inside port, and then the name of the image. And our image was called Lunis. So I run that, and then once it's running, I'll be able to go to localhost colon 8123, and then I see it. This is my file. But this is running from my Docker container. It is not running. The other one we are running was from, this one is from our local host. But this one is running from the actual Docker container. Even though it says localhost 8123, it is running on localhost, but it's running the code from the container. So if I were to change stuff like, this is my file, like this says here in the index.html, this is my file, and I would say, put some dots in there, and some arrows. You'll see when I change that, that will run, this is running from my local host, so it picks up the changes. But if I go into the container, and I refresh the container, obviously the container doesn't know anything about those changes because it's running inside of the container. This code is running inside of this box that I have no real direct access to. Containers, once a container is running, you're not really supposed to have any direct access to it. It's just serving you a file and application, and you're really not, the idea is you're not modifying the container, you're just having the container do a job for you. Serving up routes, serving up data from a database. It can serve up data from a database, but you're not going to alter that container. You can alter a database through the container, but you're not going to alter the container. Okay? So Yeah, so we did the I do, I did this by myself. We did the we do. The class explained every single one of ones of the lines of code here. All right. So now let's do another we do. We're going to make another Docker file. Or actually, we'll modify this particular Docker file. We're going to make a new image, and I'm going to change the location of my index.html file. So now I'm going to go into here, into Lunes, and I'm going to do what we had before. We're going to create a new folder, new directory, and we're going to call this our files. And I'm going to take this index.html and I'm going to stick it in our files. And now this is in our files, which is at the root of our directory. If we try to run this, then it will create a server, but this index page is not going to be at the root of the directory. So when we serve up the server, then we'll see our files at the base. So let's look at what that looks like when we just do it HTTP locally on our machine. If I do this, and I cd into documents, gschool, USA Lunes. So you see we've got my files, we've got our files, but there's no index.html in here. So if I run a simple HTTP server in here, I can do Python 3-m http.server, and I'll just run it on some port like 5009. It'll run a server. But it shows us the directory listing. And then we would have to go into our files to actually see that file. We don't want that. We don't want to run the server and then have people looking at this ugly directory listing. We want to something about our Docker file needs to change so that we copy the right files into our working directory. All right, so let's take a minute to think about that. Just 20 seconds, and then I'll take a volunteer to tell me what we need to do. The question at hand, by the way, was if we were to create our container now and run it, it would look like this. We don't want that. We want to take the index.html file and add it to the working directory. But we need to add it properly. Okay? All right, volunteer. Who can tell me how can I get that to work properly if we build the image? Craig, how can I correct this Docker file so that it builds the image properly? So that our server when our server runs, it'll look like this again. Uh-oh, is my volume down? It keeps on saying 2 participants raised their hand, but there's no hand raised. That's weird. Craig, are you here? I can hear you. Yeah, I can hear you now. So my sound must be cutting out, and I see. Were there people putting in the chat? Because I don't see any new chat. Okay. No. Okay. All right. Oh, you're raising your hands. Okay, I'm sorry. I need to. Okay. Yes, go ahead. Yeah, our files to the second dot. So let's make a new one. Docker build dash T. We call this one martes. Okay, I see some hands, but I can't see who the hands were. So who was the hands? Go ahead and if you raise your hand. Aiden. Yeah, I think yes, I think so. Yeah, .r files to say from here, then there. Now I think it actually might work with this like that one. Let's try this first. But this is guaranteed to work because it's going to tell it from here, go there. But I'm curious as to how this will. We can try both ways. Let's try it without the dot first, and we'll just call this one martes. So docker build dash T martes and then a dot. And let's, yeah. Now the second time that you run a build, it's going to be a lot faster because it's already cached the files from the Python image. So it should take a little less time. And I should have changed what was in the index.html file so we can know there's the martes image, but it's okay. All right, so then now we want to do docker run dash P and then another port, so we'll just do 5111 and then it's coming from 588 like that, and then we're running the martes image. Let's see if just the slash worked. Localhost 5111, and it worked. But technically speaking, yeah, I think the dot is probably the better. It's just less ambiguous. Dot always means start from the current directory and use that as reference. So you can use the dot there. It's fine. Okay, so we've done it twice. We've gotten feedback from the class. I think you all have kind of a base understanding of how this stuff is working. What we want you to do is create a simple HTTP server like we did here in class. And we want you to take a video of yourself doing it from start to finish. Make your HTML file. And you should be able to do it within 5 minutes so that you can do it within the realm of the free account. So you may want to practice it a few times just so you can be fluid. Make your HTML file, make your Docker file, do your copies, do your ports, expose it, build it, and then run it. The only other thing that you're going to have to do is you're going to have to push it to Docker Hub. So we're about to do that now. So I'm going to, the last thing, and boy, this is going to be a long recording, and I apologize. Take forever to upload, but I think that we have cheat sheets in the slides. So you have everything you need to do in the slides, but the Docker Hub part is not in the slides, so you have to pay attention, please. If you want to get this up, you need to do Docker. So I have an image already. One's called Lunes, one's called Martes. I could do Docker push Martes. So you have to put your name for the name of your Docker Hub account, Martes. Here. Docker push imuta / martes latest. No, it doesn't have the tag. I think maybe I have to build it to push it to my, I think I might have to build it to push it to my local. I'm forgetting. Let's try building. So I built the image to push it to my Docker Hub. And so it's pushing the image, and in order to verify that everything on the image is correct, it's actually going through the same process that it did when I was doing locally. And now it's pushing it to my Docker Hub. Okay, it says it was pushed. So if I go to my Docker Hub, here's Inmuta/Martes, and if I go into it, for other people to know, since they don't know the internal workings of my container, it's really good etiquette to put runs on port 888. So inside here, it doesn't have a description. I'm going to put runs on port 8888, simple Python HTTP server. Then, if you go to Docker Hub and you search for Inmuta/Martes, then you'll find my image. And then you could, on your side, you could do Docker pull Inmuta/Martes, and you would get my image. So that's pushing and pulling from Docker Hub. Any questions about the Docker Hub pushing and pulling process? So I will say that in the daily plan, you'll see here that in the, not the slides, but the, what the assignment is you have to create a simple HTTP system on your system, HTTP server on your system, save it, containerize it, and then send it to a friend so they can pull the image. Make sure they include the port name in your Docker Hub repository, just like I did. And then you turn in a video of your containerization process here. So that containerization process, as much as you can fit in the 5 minutes, we should at least say you being able to containerize it. I suggest doing it a few times first as practice, because the first time you do it, it's going to take longer to build the image. The second and third times is quicker, and it'll just make a faster video. That way you don't have to spend all your time with the video.